So good evening, everyone. Hello, everyone online. My name's Mark Stanley, and we're talking about Lorawan in Berkshire. So hopefully you've come to the right event. Why are you listening to me? Hopefully I can tell you that. My company is called Thames. We're based here in Reading. And we've been working with local authorities for the past, since 2016. So we help them use IoT to deliver services more effectively, hopefully improve the daily life for people, removing friction for them, and trying to stimulate economic development. One of the things I've been able to do, and it's been down to council funding, is employ some young people. So the two young people that you see on the screen, they came about because the council gave us some funding. So I was able to employ Tracy first, and then later Will, and you'll hear a bit more about them, I'm sure. I'm also the ambassador in the UK for the Things Network, and I co-organise a conference called the Things Conference UK, which I've done with Emily up in Norfolk. So this is what we're going to cover. We'll start off with sorry, it's a bit of a blunt question, but what is the point of the Internet of Things? And then talk through the Smart Berkshire IoT network and how that came about. Then there'll be a slightly more technical section where we look at the different Internet of Things technologies and Lorawan in particular, so a bit of a comparison between technologies. And then I'll be showing you some example applications in Berkshire. Not all of them are from my company, so you know, I don't feel particularly precious about anything here. At the end, assuming things go well, I'm going to walk through an IoT application and hopefully do a live demo of stuff working. Fingers crossed on that. Please, in the room, do feel free to ask questions as we go. It would be good to hear other voices other than my own. And I know since we've all been in lockdown for so long, our attention spans have diminished. So I will try and change it up as we go along. So hopefully it will be all right for you. Okay, so we start off with what's the point of the Internet of Things? And in fact, what is the Internet of Things? So the way it's defined in the global encyclopedia called Wikipedia, they talk about physical things. So it could be a smart bin, it could be a building, it could be a person, it could be a pet. There's a lot of people tracking cats and dogs around. But it's a physical object, and added into that are some sensors or actuators. So hopefully this will work for everybody, but in my hand is a smart bin sensor here. So it's the little black box you can see on the screen there, and that measures the height of the rubbish in a bin, which is useful if you add some connectivity to it and some software, and you give it a unique ID so you know where it is, because then you can start building a system around it, and you can maybe reduce the amount of mileage that a van driver has to travel. So it's good from a carbon point of view. You know, maybe you save them some time and some money, but also maybe one of the things that you do is make the bins always, you know, unfull. So it's actually better service for the public, which is what the councils are trying to achieve. And that really points to the nub of what is the point of IoT. It is all about being able to use data from various objects to make better decisions, to improve the service quality. If you can save money, then that's great for a council, and for a business, of course, if you can make money, that's even better. And if you can improve the quality of life for people. So in the news, there's been quite a lot of interest in care for the elderly, trying to reduce things like falls in older people, and providing better care for people who have dementia. So these are all cases where people are trying to use the Internet of Things. So I want to introduce you to the Things Network. This is, well, it is a global, open, crowdsourced Internet of Things data network. It didn't start out like that. In 2015, it was the idea of these two people. So this is Winke and Johan from Amsterdam, and they'd heard about Lorawan, and they decided they could create an Internet of Things data network in Amsterdam. And so they got some friends together, and between them they bought some gateways, which I'll tell you more about later, and created a network across the city. That cost them less than 10,000 euros. And I heard about that and was very excited. And previously, obviously, I'd heard about smart cities and the Internet of Things, but I thought it was for the likes of Cisco and Microsoft, and not the likes of me. And there's nothing wrong with Cisco and Microsoft. You know, they play important roles. It's just this particularly grabbed me, not least because I go to Reading Geek Night, and I had a feeling that there were enough geeks in Reading that maybe we could do the same thing here. And also Reading is quite a bit smaller than Amsterdam, so maybe it wouldn't cost 10,000 euros. And it turned out I was right. It also turned out that I wasn't the only person who thought this was an interesting idea. So now worldwide, there are 170,000 members to the Things Network. It's in 150 countries around the world, and there's 20,000 gateways now, some of which are about 120 of which are in Berkshire. So in the UK generally, there we go. So in the UK, we've got 104 communities. There's 862, the 2 is very important, 862 gateways, 120 odd of which are here in Berkshire. And that's thanks to a large part in the community of people around here. So there have been people interested in the Things Network from, well, right from the very beginning. So there's a guy in Thatcham who was interested in it just before me, to be fair. And so there was a community already forming here, and we were very much in the UK at the forefront of it. So when we started, there was about a dozen gateways in the whole of the UK, and about 8 of those were in Berkshire. So so it's gone well for us. Right, so in, I think it was 2016 originally, Reading Council put together a smart cities bid, which they didn't win. Manchester won it. But the ideas that came out of that resonated well with the council, and later, and around 2018, they got an opportunity to bid again for a smaller amount of funding. But they kept those ideas together, and they created what they call the Thames Valley Berkshire Smart City Cluster, which just trips off the tongue. So everyone else calls it Smart Berkshire, which seems to work a bit better. And what that delivers is, firstly, the aim of it was to deliver an LP1 network, so a Lorawan network across what was at the time 4 councils, but has now become 6. And there was also, of the 1.7 million funding, about half of it was going on to innovation and local economic development. So the council set challenges to business generally in Berkshire, who could bid, basically pitch for the work. And we'll just let the bus go past. So who could pitch for the work? And what follows, hopefully, yeah, it's actually a slide on. The coverage of the network is now across the whole of Berkshire. So this is 3 years later, but we've got coverage on about 90% of the population of Berkshire. So obviously Reading, Bracknell, Wokingham, Newbury, Field, Thatcham, Maidenhead, Slough, Windsor, they're all well covered. There are obviously patchier areas in the more rural spaces, but we do have extra gateways to fill in those gaps as the need arises. This is a video. It's a 4-minute video. It will be someone else's voice, so I'm going to play that now. This explains what the different challenges were, or the winners of the challenges.
The Smart City Cluster project, backed by over £2 million of Thames Valley Berkshire Local Enterprise Partnership funding, aims to demonstrate how smart technology will help councils deliver better public services. Here we'll show you some initiatives that explore its potential. 3 million over 65s fall each year in the UK, costing the UK government over £3.4 billion per year. The falls prevention system uses smart technology like LightPath to help light the way from bed to bathroom at floor level. Data from remote sensors is fed to the system, reassuring residents or alerting carers and relatives. Councils spend a lot of time dealing with inquiries about waste and highways. Using an automation platform, IntelliAgent, we have developed chatbots to answer common questions, saving lots of valuable time for key services. In the UK, 500,000 older people go up to 6 days without speaking to anyone. Joy is a web tool developed to help combat loneliness in the community. It's used by care professionals to connect clients to the right services or groups. Another initiative is Waka, an app designed to help residents explore the culture and entertainment in their area, from history, landmarks and surroundings, to shows, classes and clubs. Many women students are understandably worried about walking at night. The Myway student safety app uses sensors positioned around the streets of Reading to send data to an on-screen map, giving reassuring details about light levels, activity and noise. Developed by Ethos, Independability provides vulnerable people with live information on the availability of buses and indicates how busy they are too. It helps make public transport more accessible and reassuring for vulnerable, isolated members of the community. Eco Rewards encourages cycling and walking while aiming to cut car journeys. It uses smart ID technology to record green travel choices. Congestion and pollution go down as quality of life goes up. Users can access a range of rewards for taking the healthy option. Meanwhile, Measurable Energy is a platform designed to help commercial building managers cut building energy by at least 20%. Combining smart power sockets with cloud software and machine learning, the platform automatically controls building energy and emissions. IoT specialist Think Engineer has created a solution to fight fuel poverty and poor living conditions in social housing using smart sensors. And they're also launching a complete IoT ecosystem called ThingPilot to enable the development of more innovative IoT products. Discover new solutions for your community with the Thames Valley Berkshire Smart City Cluster project.
Did you like the piano? So it's a great idea, and to some extent it worked well. we were severely hampered with COVID lockdowns. So not every project got to happen, but quite a few did. And I will talk about some of those next. In fact, I'm going to skip through these slides now. Or at least I'm not going to read them out to everybody. We'll have a look at the website a bit later of Eco Rewards, but that was the one that is trying to incentivize people to make green choices and a more active way of traveling. That, as you'll see, that's worked well for them. Started in Bracknell and they've expanded from there, and they had to adapt because of COVID. So rather than the businesses that they were intending to work with, they started working with schools because kids were still at school, and it worked well. And they've expanded the school bit, and now they're doing a lot of active health stuff in Bracknell. So on their website, which I'll show you at the end, they've got some results from that. The falls prevention system was one of my projects. That one, as a technical proof, worked very well. We know that by putting passive sensors in people's homes, we don't stigmatize people. So older people don't really like wearing the pendants and stuff that really just point them out as a patient, or in some way vulnerable. And so instead, what we were tasked with doing was using sensors around the house. And there are systems out there that will detect falls. We weren't trying to do that. What we're trying to do is prevent them happening in the first place. So we're looking at the risk factors around falls. So whether someone is dehydrated, whether they are too sedentary. So if they're sat down all the time, it actually increases their chances of a fall as they move around. So also if the room is too hot or too cold, there's various things like that we were monitoring. And as a combination of data points, you can build up a good idea of what is happening to that person. And you can spot changes over time. One of the partner companies I worked with there is called Tendertech, and they have since got considerable amount of funding and are working in a more of a higher care dependency area, looking at exactly how people move around. They've got some fantastic technology for that. What we found, and it is something I'm sure a lot of people in IT have discovered, is that sadly technology isn't the whole answer. And what you actually need is quite a lot of organizational change in social care so that people can actually respond quickly to these kind of, this important bits of information. Because if you can say Mrs. Jones is getting wobblier and wobblier, maybe she needs a walking frame, and someone can actually deliver a walking frame to her, then you can genuinely reduce falls. But if you are stuck with a social care system that does annual reviews of Mrs. Jones, then it's unlikely that the timing of that is going to work well. So the technology is great. We know that we can spot changes in people's behaviour, and we can spot risk factors, but there needs to be a much more fundamental organisation change within the way care is delivered to people for it to really take off. And the third one of those challenges that I wanted to point out was measurable energy. Now this one actually doesn't use the Lorawan network. I think it's based on Wi-Fi, but it's a really nice idea. And what they're doing is replacing the plug sockets in offices with smart sockets that can, well, for example, they can turn off the coffee machine at night. And that kind of thing, and actually manage energy much better. So I think they claim, 40% energy consumption savings in offices, and they, in the last couple of months, received a considerable amount of investment for that, which is very exciting for this area, really. Okay, so we should have a look at the component parts of the Internet of Things. So hopefully this will make sense to people. So on the left-hand side of the screen, you've got the things themselves. So these are your various sensors. So it might be your smart bin sensor here. This one is a smoke alarm. This one's a mouse trap. So there's a whole range of different types of sensor. They're all real. And they send data, they transmit data, and that data gets picked up by a gateway or a base station, depending on the network technology. But the gateways work very much like the Wi-Fi box in your house. You know, it allows a wireless device to send data to it, and then it passes that data on to the internet. I'll talk about some of the differences in a minute. Now, in the cloud, obviously, this data gets passed on to a network server, and then that network server has the job of forwarding the data on to the right application. So one of the examples I like best is lift maintenance in blocks of flats, because lift engineers are, well, I suppose there's two things. Residents of blocks of flats complain bitterly when lifts break. And you know, not surprisingly, because it can leave people stranded many floors up. Lift engineers report very often that when they're there fixing the broken lift, someone will walk past and say, oh, it's been making a funny noise for weeks. But nobody called the engineer company because they don't like to cause a fuss, because they're human, and you know, that's how we work. Putting sensors in the lift that listen for the funny noise and having that automatically call the engineering company out to do preventative maintenance makes a lot of sense for everybody. It makes it much cheaper to do the repair because you can schedule it during normal time. And also for the residents, it means that you know, you don't have the same level of outages, and it can be something that's actually planned. So in that case, your sensor would be in the lift. It would transmit, there's a funny noise in lift 3 of building 4, which the gateways would pass on to the internet network server, which would then forward it on to the works system, where an engineer would get called out to make the repair. So that, I think, it's high level, but that's how pretty much all Internet of Things systems work. What makes the difference really are the different types of network technology. So this diagram is meant to help explain some of that. So if we take, for an example, RFID, which is the technology that's in your payment card, now that has some interesting properties. So there's no battery needed for that, right? There's no battery in your payment card, and yet it works. But it only works over a very short distance, doesn't it? Because you can't pay for something all the way over there. You have to tap the machine. And it only transmits a tiny amount of data. So that technology is very useful for payment cards. It would be rubbish if what you wanted to do was stream Netflix, right? It's just not possible. For that, you need something like Wi-Fi, where the amount of data you can put through Wi-Fi is huge. But you can only do it over a short distance, right? It works in your house, might even work in your garden, but it doesn't work down the street from where you are. Also, from a power point of view, Wi-Fi devices, as hopefully we won't discover tonight, but the battery-powered Wi-Fi devices, you know, the batteries last hours and days, don't they? They don't last longer than that. So, you know, it's suitable for some things, but it's not suitable for everything. In and around the home or the office makes loads of sense. If you go further than that, then you're looking at the mobile phone technologies. So, 4G, 5G, and there you've got enormous amounts of data again, traveling over a long distance. But similar problem to Wi-Fi devices is that the batteries don't last very long. So you couldn't, for example, put a mobile phone type thing in fact, in a smart bin sensor, right? Because you would be opening the bin every night to charge it up. That wouldn't make sense. Whereas if you get it right, then a sensor like this can last maybe 5 years in a bin before you need to worry about replacing the battery. And that kind of stuff happens with the Lorawan Lp1 technology. So this is low-powered wide area networks. And with the low power bit, that's what enables the batteries to last many years, coupled with the fact that they can only send tiny amounts of data. So to put that into context for you, about half a tweet is what they can send. So 50 bytes is kind of the top end of what you can get in a LoRaWAN message. And really, you should be aiming to send less than that, because it will prolong the battery life by being on the air, or being on radio transmitting for a shorter time. So it sits, as you can see, in a totally different area to 4G and 5G and Wi-Fi and RFID. And what that means is that there isn't going to be one answer for smart city type technology or Internet of Things stuff. It is really a question of picking the right sort of technologies for the job. Sorry, John. For the people online and anyone else in the room who couldn't hear that, John was saying that there are some other advantages of LoRaWAN beyond distance and battery life, and he's absolutely right, and I will get to that, I think, in a slide. What I wanted to say before I finish this one is there is other technologies around. So there's Bluetooth, there's Zigbee, there are many network technologies. People have tried to make different lists and just stop once they get into the 10s and 20s of different technologies around. They all have different properties. So Zigbee, for example, is the kind of technology that's in your smart electricity meters at home. Interestingly, with the smart water meters, a lot of companies are looking at LoRaWAN as an alternative, and John's point plays to that. So there are some good uses of LoRaWAN. Status monitoring and alerts is an obvious one. So the smoke detector here is a good example of that. It will send out an alert if smoke is detected. Similarly, the mouse trap will send out an alert if it catches a mouse, and it will send out an alert if the mouse gets away, because someone has to go out and rebait it. So, so we've got that. So lots of different examples there. Counting, whether that's counting people. So a lot of interest in monitoring footfall. And when we get to talk about the student safety app in a bit, you'll see an example of that. But water meters is one of those use cases. And where you can do preventative and predictive maintenance. So like the lift example is a good one of those. Also for remote control. So you could be monitoring a water valve in a field if you're a farmer. There often isn't 4G in farmland because there's not the people there to justify it. But it's very easy to stand up a Lorawan network and provide coverage for yourself. And you only need a tiny amount of data to, open something up or turn something off. And asset tracking is another example. So this tends to be more around depots and things like that. If you want to monitor, the whereabouts of different containers. So ports is one area where asset tracking is being used quite a lot. In the UK, you can't really use at the moment the Lorawan networks because they're too patchy around the UK to give you very granular data for asset tracking. One of the exciting things coming down the line is using Lorawan with a satellite backhaul instead. So there are several companies now. In fact, there's one very close to us up in Oxfordshire called Lacuna Space that is deploying a constellation of satellites that will allow Lorawan devices to speak directly to that, which opens up all kinds of opportunities. As John said, one of the other advantages Lorawan has is that it can penetrate into buildings quite well, and through some buildings and indeed into basements, which makes it suitable for things like meters and water meters because you can actually get deep into buildings with it. It's also being used, I don't think people saw it coming necessarily, but increasingly in building management where like building management systems have existed for years and years and years, but what people are really liking is that you can just literally stick a sensor to a wall, and that's as hard as the installation gets. You don't need to run wiring everywhere. It makes installing buildings and warehouses really quick and therefore a lot cheaper. So people are very excited about Lorawan for that. But it really isn't good for everything. If you want to send large amounts of data at a time, then it is not the network technology for you. As I said, 50 bytes is kind of the most that you should be looking to send, and really, if you can do it in less than 10, that's a good thing. But you can get a lot of information in less than 10 bytes. You can this device here. What does this tell us? This tells us the level of CO2. It tells us the temperature, humidity, particulates, so air quality. It gives us all that in one message that comes out. I can't remember quite the length of that, but it's nowhere near 50 bytes long. We can have a look at it later. I'll plug it in and you can see it working. I quite like that one because it's got an e-paper display as well. So it means that, you don't necessarily need the whole internet thing to see the information. So if you're in the room, you can just see what it's telling you. You can't use Lorawan for continuous transmission. So Lorawan in Europe and as far as radio world is concerned, Britain is still in Europe. So you can, everything is transmitted on 868 megahertz, but it's a bit of the radio spectrum that is exempt from license. That means anyone is able to use it, and it isn't just Lorawan that uses it. So lots of different radio technologies use that. But there are rules around its use, and what is imposed on you is a duty cycle, which means that you can only send data every so often. And the practical limits of that are sort of every few minutes. But if what you're looking to do is preserve battery life, then really you should be looking at use cases where you're only sending data a few times a day that's a way. But I don't want to overplay that too much, because the sensors that we've got monitoring the streets of Reading have been installed for over 2.5 years, and they send data every 15 minutes, and we haven't had to replace the batteries yet. So, you know, it's not as awful as that. You don't get an instant response, so it uses radio, and it uses some very clever techniques to make sure that the messages get through. What that means is that you don't get a response back like that. It can take some seconds. So there are use cases where that's not, you know, makes it unsuitable. And also, I would say for truly life or death use cases, where it really is life or death type things, then it's not the technology for you. A good example of that is monitoring traffic lights. So monitoring the traffic lights around Reading, you can do that with Lorawan. That works fine. It's very, very good. It will tell you whether the lights are working or not working, and it will count how often the pedestrian crossing buttons are pressed. But controlling the traffic lights is not something that you would do with Lorawan. I think that's the sort of distinction that I try to make. Okay, I've spoken for a bit, so now we're going to hear from Mike. So Mike is someone who's worked with me for, 5, 6 years, something like that. I've known him from Reading Geek, and he was there when right from the very start. This is a project, or it's a couple of projects that have been going on in Reading and then in Wokingham around using Lorawan in a slightly more agricultural way. So this is about 6 minutes of me not talking.
Welcome to my presentation. I'm Mike Beardmore, part of Vigilant. For over 6 years, I've been pleased to help the growth of the Things network. I'm keen to promote the use of LP1 and have aimed to prove that it is easy to use, valuable, and to show its potential for education and community groups. In 2015, I and others hosted gateways, gave coverage around Reading and Wokingham, and when the Smart Barks network was born, I helped install access points on traffic lights, but was pleased others did that on 12-metre poles. We tracked the actual on-the-ground coverage with simple DIY devices, finding both hot and not spots, learning more than one needs to know about RF propagation and Frenzel zones. We deployed sensors in a raised bed at the Museum of English Rural Life in Reading. They proved both the effectiveness and limitations of LP1 wireless for connecting sensors. A professor from Australia chose sugar beet for her PhD project. We learned a lot about deployment from the opportunity given at Merle. Robin was keen to record the growth conditions above and below ground. At the Hackspace, we built a custom sensor hub for a microbit, recording soil, air and colour light levels. Challenges included weatherproofing, meeting university protocols and spiders. Data was collected over the 1-year sugar beet season and for a 2nd year with another student's companion planting project. Data was shown on a web display hosted on the EMON open source energy monitoring platform, adapted accordingly. The Wokingham project is linked to the Wokingham Town Council's provision of allotments for the new homes community. At this stage, we are collecting and showing data and daily values on a dashboard available to the holders. One allotment is in a valley and one on a hill close by. It's been surprising how values vary between these two locations. From our experience of building our own sensors, we wanted plug and forget devices, so we chose an off-the-shelf sensor. We had a choice of two versions from Tektelic. One is a post-mounted and has wired sensors. The other one is compact, a just stick in the ground sensor, which is the one we chose. They are manufactured by Tektelic in Canada and purchased via UK distributor Connected Things. They have firmware optimized for low power and measurement accuracy. Weatherproof to an IP standard with support via documentation, a forum and access to online engineers. We see this sensor offers good value compared to building your own. They provide soil moisture, soil and air temperature, air humidity and light levels. They have alerts for being tipped over and low battery state. Battery life is estimated at 10 years, something we have yet to prove. They come pre-configured and in deep sleep. They are simply activated using a magnet. Device keys and details are on a QR label and are set up on the Things Industries console using this information. Changes to sending parameters and others are done by downloading via a wireless link. This is something that does require being within range of a gateway, something that is best done with a survey. I learnt about how approval for funding and COVID disruption can elongate a project rollout. In January 22, the sensors were deployed easily and quickly. However, choosing the best locations is something to be thought about. Direct sun will give raised air temperature, so shielding or finding a shaded place would be best. Leaking taps could be detected as well at this location, and how effective drainage is working in other places. Being so close to the ground, we wondered about antenna performance, but we get several smart box gateways covering most of the allotment areas, with a Twyford gateway reaching there from over 13 kilometres away. This is supplemented by my own indoor gateway that is only 1 kilometre. You're most likely familiar with the 4 Lorawan components. The application server we chose was AWS. We're hosting a version of the Thingsboard application server. It's required to receive data, store and host the dashboard. This shows the dashboard viewed on a desktop browser. Thingsboard is available on AWS as standalone and hosted. It provides better account control than I found with Grafana. There are lots of choices available, and this has a responsive design. You can change the parameters you see here and choose the different graph parts. A text area is shown, which can be used for adding to a spreadsheet. The responsive design version is suitable for mobile phones and less data intensive. So whether to build your own sensors, your own dashboard or service, or you want simple off-the-shelf simplicity, we have experience with all. Whether a garden plot, an allotment, or a school plot, or even a giant tulip farm in Norfolk, something I never knew existed. Thank you for your attention to the presentation. Look forward to meeting you again, answering more questions in person or via Zoom.
So there you go. That was some agricultural examples. What I really like about that is it started out very much at a community level and then got picked up by Wokingham Town Council and became something a bit bigger. And Mike alludes to the potential of that growing. The next example I've got is the traffic light status, which I jumped the gun on and talked about already, so I will skip over that. Reading Hydro, does anyone here know Reading Hydro? I know Stuart does. I know Chris and Judy and Annette, yes. For those of you who don't know, Reading Hydro is a community project. It's created hydroelectric generators on the Thames at Caversham Weir, and it's 2 Archimedes screws, and the electricity is currently sold to the Thames Lido on the other side of the Thames. We are using Lorawan there So I got involved because I was helping provide the data feeds out of that building that you can see and onto the websites. And we got involved because Lorawan can send some data from there. So we're monitoring security on the site, smoke detection, that kind of thing there. We also publish all that data to an open source, to an open data platform, so that anybody who is interested in hydroelectric generation can do research with the data that we're building up. And it's been running for, it's not quite a year yet, is it? But it's getting on for a year. So there's a good data set being built. Falls prevention system we talked about earlier. So I will skip through that one. Myway is our student safety project. And you remember at the beginning of this talk, 6 hours ago, I told you about Tracy, who was someone I was able to employ. This was her idea, and we pitched it together to the council, who agreed that it was a good idea. I got Tracy to do some research at the university as well. So she surveyed a lot of the women students at the university. There are 9,000 women students at Reading University. 3,000 of them belong to a group on Facebook, which is all about pairing up so that you can walk home together at night. So we had an idea that it was a real problem for women students, but we didn't realize quite how big a problem it was. The survey told us that it was a real problem. I mean, Tracy told me it was a real problem as well. It's just, as a 50-year-old bloke, you know, it's not so obvious to me, because I can walk home at night and it's fine. So this was a project that got funded. We got support from Reading University Students' Union, who've been absolutely fantastic throughout. So the welfare officers there and the people in business development have been really brilliant. What we've done is cover 120 streets around Reading. So that's everywhere in this bit in the town centre within the IDR. And then out to Newtown and Palmer Park, and then up to the university campus at White Knights. So there are sensors on all the streets there, and they monitor things like people movement, light levels, and we've got some experimental sensors that are, well, to be honest, they're not working very well in terms of what we're aiming to do is to say, is it a happy street or an angry street? But it turns out our AI skills are not quite up to that. But we can tell whether it's, you know, whether there's traffic on the street, whether it's noisy, whether there's people, whether there's children. So it's getting somewhere, but it's not as useful, it turns out, as how many people are on the street or how well lit is the street at night. The other thing that we gather is reports from the students. So if anyone sees a dodgy guy on a street corner, or if that's something they can record on the map. And so all the students have this this app, and it's a map. I'll show it to you, and they can then see and work out the safe way home. We launched it in 2020. After the first lockdown, we did a little trial to see whether it would work. We got more signed up for that than was expected, which was really encouraging. And then the government kindly put the second lockdown in 3 weeks later. So it gave me a lot of encouragement, but what it didn't answer was the real question I wanted to know, which is, will students keep using this, you know, once they've installed it? Or is it something they'll install because, you know, they want their parents to think that they're being sensible, but never actually use it? So it was encouraging to see that in the 3 weeks in between the lockdown, it did get used, but that wasn't really proof that it would carry on being used. So September last year, we relaunched it for the freshers. We made a few changes based on the feedback from the first trial, and it's gone really well. So sign up was good. The first semester students were using it heavily. So that's obviously the winter term. So we were getting a lot of usage then, and it has eased off for the new students throughout this year. But that's as the evenings have got lighter, and also as people are familiar then with the town, they don't feel the same need for it. But very encouraging, and the Students' Union and the university we're doing it again this year because there's enough interest in it, and that's really good because it's given me the confidence that I can start approaching other university towns as well. There's plenty around the UK. I think there's 1.1 million women students. One of the interesting things is that it isn't just the women students that use this. So Reading University, they made it open to everybody. And this year, one of the things that has cropped up that hadn't in the previous year is the rate of drink spikings that go on in clubs and bars around town. And it's not just Reading, this is countrywide. So we've added a new feature in which allows you to report if your drink has been spiked. The idea of that is that we can then build a heat map up of the dodgier bars and places to avoid in town. For two reasons, really. So one strand of that is that obviously it helps the students avoid the dodgier areas. But the second one is that we can start putting some pressure on the bar owners to take drink spiking more seriously than they have. So hopefully that's going to make a real impact. Should also say that the police are they run an operation called Operation Vigilant, which is about street harassment and violence against women at night, in particular in the nighttime economy. So they're interested in getting some of that data as intelligence for their own operation. So we get without all the dodgy stuff, we get bus data as well as the sensor data and the crowdsourced data, and that all goes into the app. And if we're really lucky, right, this is my phone. This is the app. So you can see there. Well, what you're seeing is a live picture of people moving around Reading town centre. We can, if someone's out at night and they see something they don't like, they just press the report button, and they can record whether a drink's been spiked or if there's drunks just abusing women. So that's easy for them to do. They can see their friends on the map. So if they're trying to meet up in town, it's quite easy. They can also use it, and this is very popular. They can use it to text their mum when they get home at night, and it does that automatically. So you can get home and fall straight into bed. The app knows that you got home, and it will text your mum to say that you got home safely, so that they can go to sleep as well. Also, one of the things that I haven't appreciated quite as much, but listening to the police, the number of freshers in particular, so students new to Reading who get lost during Freshers Week because they've forgotten where they live and don't know the way home. So we've got this Take Me Home button, which is not going to work here because I haven't got a SIM card in here. Brilliant. Okay, nearly worked as a demo. I can show you on my actual phone how it works, but the idea is it gives you a route home from wherever you are. Maybe it does know where I am. Let's give it a go. Doesn't know. No. There we go. Okay, almost worked. I'll show you on my phone if you're interested, but it shows you the route home, and you can switch between walking or bus. One of the things with students, of course, that makes them more vulnerable than other women and other people is they haven't got much money, so they don't spend it on taxis on their own. You know, it's better to have a good time, which makes sense. So they will get taxis if they're in a group, but if they're on their own, they're much more likely to get the bus or walk. So finding a safe route home that avoids another slightly interesting thing. Some women really want to walk home on the busy streets where there are lots of people going past. Some women, and it's a good proportion of them, would rather walk on streets that are completely empty and just sort of go home unnoticed. Absolutely nobody wants to walk home on the street where there's just one person on a street corner, which, you know, I think when you talk it through makes lots of sense, but it's not something you think of when you're designing these kind of apps. So it's been really interesting to see how things have worked. This is the, sorry, I know it's the BCS, so I thought we would need some kind of block diagram here that will talk about how the application actually works. So we've got our, in our standard diagram, we've got the network server in the cloud. That forwards data to our setup, which is, as Mike said, it's in AWS. So we have a message collector program that takes the messages from these 120 street sensors and shoves it into a database. And then we've got an app, which you've just seen, and that gets the data via a server, which pulls that information out of the database. And the data comes in through another API. So hopefully that makes sense to everyone. I thought you'd be interested. It's written, the server side is written in Go. Does anyone here use Go? Some people are a bit to use Go. I found it, I've really enjoyed writing in it, actually. It's my favorite language at the moment. It's very fast. Hello. So the question there was, are we hosting the various boxes here on AWS as services, or are they actual hosted instances? Is that right? Yeah. So are you thinking lambdas and yes, serverless stuff? It isn't serverless, no. We're using, I think this is actually using a Lightsail instance, or a couple of Lightsail instances, one for the application server, one for the database server. So, yeah, I think, so I am interested in going down the serverless route. I think that there could be some good opportunities there. I'm a little bit reluctant to go all in on AWS, if I'm honest. So I don't want to commit wholeheartedly to lambdas. Right, so what I thought I would do, you've had quite a few examples now. I thought I'd dive a little bit deeper and try and explain how it actually works. So we've hit the bus rush hour. What happens when you connect a device? How does it know that it should talk to the smart Berkshire network rather than any other network that is around? You know, if all these things use 868 megahertz, what makes this device talk to the right application? How do you do that? So with LoRaWAN, devices join, they join the network first. So there's two steps to it. First thing they do is, actually, let's take a step back. Any of these devices has a series of keys on it. has something called a device EUI, which is a unique identifier that says this is the device's ID. So that's its fingerprint, if you like. Then it has something called an app EUI, which says which application it's allowed to talk to. And then it has something called an app key, which is it's an AES 128-bit key that it uses to decrypt and encrypt messages, because we don't want people intercepting the messages. The whole thing's encrypted end to end. So because I'm not sure if this is the real reason, but conceptually, because the device manufacturers have no idea what application you're going to join, they have to allow you to change things like the app EUI. So with all these devices, there's generally a way of configuring elements of them. What you really can't reconfigure is the device EUI, because that's its unique ID, right? So what happens is the first time you turn it on, a join request is sent, and that sends its identifiers. So the device EUI and the app EUI get sent, and they just get broadcast. So smart Berkshire gateways will pick them up. Other types of gateways will pick them up, and they will look at they'll pass on the device EUI and the app EUI to their respective network servers, which will then look to see whether that's a valid combination. Does it exist on the network server? Has it been configured on there? If it has been configured, then it will send back a join accept message. And that join accept message contains a whole load of session keys in encrypted form. So this says, these are session keys that say, yes, you can use our network. You've got permission to use the network, and yes, you can use this application. It's those kind of session keys, which means that if further down the line, so you have to turn it off and turn it back on again, or permission gets revoked, you can just cancel those session keys, and then that device is stuck. So from a security point of view, that works very nicely. So the join accept message goes back to your thing, and using the app key, the decryption key, it then decrypts it, and it's got session keys then that it can use. So from that point onwards, it will send a normal message, saying what the temperature is, or whether there's a car parked on it, or whether the lift is working properly, or how full the bin is. And it will send that with the valid session keys, and the payload itself is decrypted. So that will go then to the network server, and then the network server will, because it knows that that's valid, forward the message on to the application server. So I hope that makes sense. It can work in reverse as well. So it doesn't get used on a very regular basis. Certainly not as often as sending messages up. But you can send messages back down to the devices. So you might want to reconfigure the frequency at which it transmits. Or if it's an actuator rather than a sensor, you might want to tell it to turn the water on or turn the air conditioning on. So that kind of thing is a downlinked message. So hopefully that made some sense to everyone. Did you like the animation anyway? It took me hours. Right, so what I thought we could do is actually have a look at the network server. Are we okay for time, Chris? Yeah, everyone relaxed. I mean, we're not going to be doing this for very long, but I thought I would show you a device actually connecting, so you can see what I've just shown you as a diagram in real life. So I'm going to. I'm going to stop presenting, but that's only so that I can share my Google screen instead. So hopefully everyone's seeing this. So we are looking here at the people counter application. So this is the Things Network console. This is my own personal account. So I have a number of applications on here. You don't need to be able to. Shall I enlarge it a bit? Can I enlarge it? Right, hopefully that's a bit more legible. So the console is split into gateways, which are these are the three gateways that we look after, and then some applications here. So the people counter is the one that I'm brought along with me. That's this tiny device here. It's got a cable dangling off of it because I'm going to plug a power pack in. And what I'm going to try and do is hold it up so that everyone can see what's going on. But what you will, if I go into the live data, I should say, down here in the application, I've got one device. That's this device here. And you can see I've got the dev EUI and the app EUI all configured there. And if I go into it in more detail, down here is the encrypted app key thing as well. So all the keys are set up in here. And whenever you add a device, this is where you do it. You can add them in bulk, which for some projects, so if you're deploying a load of smart bins across Wales, for example, then being able to add them in bulk is very handy, because otherwise there's an awful lot of typing these daft numbers, and it's easy to make a mistake. What we're going to look at here, though, is clean the screen. So when I plug this device in, assuming that there is good coverage in this bit of Reading, which I think there's good coverage in all of Reading, so fingers crossed. Otherwise the whole thing's a sham. But when I plug it in, we should see this will send a join message, and then it should get a join accept message back. That'll give it session keys that it can then start transmitting how many people it thinks are in the room. So be interesting, right? Let's plug it in. Right, so it's plugged in. Oh, someone's counting. There we go. So you can see just coming in, there's a join request and a join accept message has come in. So this now should have the keys it needs, and it will start counting. And then in a couple of minutes, it will send a message through, which should say how many people it thinks are in here. So who thinks this is really counting people? Yeah, that's it. It's having a go at counting, well, mobile devices, really, Wi-Fi connected devices. So I expect the number to be, given that we're all geeks, I would expect the number to be higher than the number of people that are here. Also, it's working on a sort of Wi-Fi strength, so there might be some people downstairs that it picks up as well. Let's see what this is saying. Right, okay, that is a high number. It's saying, sorry? Yes, maybe that's it. So just for the benefit of everyone who can't see, it is saying in terms of packs, which is its people, it's saying 65. So this was better attended than is first apparent. So maybe the device itself has some issues, but you can see that it is it has connected and is sending data. Now, one of the things that we haven't talked about is, well, I did say at the beginning that it had to send, you know, a small number of bytes. So how does it know about that this is PAX? And it's also said on Bluetooth there's 57 people here. So what it actually sends through is these, if I click on this, this is all the metadata that you get for various devices. The payload itself was CA, A5, AA, and then EE. So it's a bit of base 64 encoded data, but it's a tiny amount of data. And what device engineers try and do is they pack the bits into the bytes to get the most out of it. Annette is nodding over there because, well, I don't know why she's nodding. I wouldn't like to presume, but one of the things that she was able to do was condense down GPS coordinates of her Internet of Things tricycle down in, I can't remember, was it 5 bytes? Yeah. 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 So if you didn't hear Annette, she packed GPS coordinates into 5 bytes, but it was ring fenced, so you had to be this side of Newbury for it to work. So that's let's see, that's it working. What I was going to show you was there is something on here called a payloaded formatter, which is a bit of JavaScript. How do I do that? And what that's doing is it's actually turning the bits back into something human readable, so that what we end up with is some JSON data that we can pass on to applications. So by writing a simple decoder, that's how you get your 4 bytes into something that makes sense to people. Okay. Let's see the other application I can show you. So Myway street sensors. So here you can see we've got, well, you can't see, but we've got like 112 odd, I think there is on there, devices connected, and you'll see that messages come through quite frequently on here. And that's because they're all sending every 15 minutes. So we're getting a lot of messages coming through. And the system copes with that really well. It's not, it's no concern. Tiny amounts of data and loads of them is what Lorawan is set up for. So right, I think there's just 2 more slides to go now. So only I can get to that play button. There we go. Okay, so I thought it would be useful to anyone interested. If you want to get involved in this, the easiest way, the quickest way, the simplest way is to sign up at thethingsnetwork.org. I'll leave this on the screen for everyone. So thethingsnetwork.org, that's where you can get free access to the Lorawan network. I should say we've set up the Smart Berkshire network so that any business, any school, anybody in the Berkshire area that wants to use it can use it for free. The councils are not charging for it. It's there to be used. So what you're actually using is the gateways. And the gateways are forwarding data back to the Things Network community site. So you can set up applications on the Things Network and take advantage of the Smart Berkshire network here in Berkshire. And any of your devices that work here in Berkshire will work in Amsterdam or any of 151 other countries around the world. So, so it's, you know, it's a good thing to get involved in. If you want to know more about some of the Smart Berkshire projects themselves, so the 9 in the video I showed you at the beginning, that's the website to go to there, the Thames Valley Berkshire Smart City website. There is a conference in September. I've forgotten the date, but I think it's the 22nd of September and 23rd in Amsterdam. So if you're looking for an excuse to go to Amsterdam, then the Things Conference is a very good one, because obviously, you know, you learn a lot. I learn a lot there. It's going to be really good. We haven't had it for a couple of years, obviously, same as everyone else. So it's bigger than ever. I think they're expecting about 2,000 or 3,000 people turning up in person to it. So it'll be great. It's really takes over the city when it runs. Lastly, on my own website, on the thingitude.com website, I've got some resources. So if you're interested in what should be the first device I buy, what if I want to write an application, what if I want to do some microelectronics, there's some information there and some links there that will be helpful to you. Okay, so that's the end of the talk. Are there any questions from anybody? Hello.
Well, first of all, thanks very much for this presentation. Yeah, it's great to see. I've been following this for some time, actually.
Yeah.
So I just want to ask.
What I was going to do is repeat the question, Chris, because the people online won't be able to hear, even if he has got the microphone. So, sorry.
Make a short question.
Yeah.
So what I was going to ask is, this is really great, fantastic. It's really very much feels like so much experimental. Have you seen any of the wider network, things like that? Have you seen any of it sort of transgress into more serious application and use, which is self-sustainable, verified data, etc., etc.? So
right. Okay. That's a good question. So it all sounds really good, but feels a bit experimental at the moment. Have we seen any cases where any use cases that have become fully fledged and are robust enough to roll out? There are some. There are some around. Certainly, I've seen it. What I've seen in this year in particular is councils getting a lot more interested in monitoring the environment in their offices. So as people are coming back to offices and schools, there's a lot of interest in how well ventilated rooms are. So devices like this one, which does your CO2 and particulates and things like that, are getting deployed in quite big numbers now in schools and offices. So it's quite a small use case, but that's happening fairly widespread. In Wales, I'm involved in a project that is looking at smart bins. That is still experimental, but it's looking at hundreds of smart bins. So it's growing from what was, you know, we'll try 1 or 2. We're now trying hundreds. But I think broadly, it is for a lot of businesses, certainly in the council world, in my experience, it really is still, we're doing pilot projects or we're doing phase 1 type projects, but it is getting bigger. And I think that's the encouraging thing. We all thought that it would happen quicker. I think all technologists are secret optimists. We all thought it would happen quicker. I think COVID has made a difference, you know, certainly in the public sector, because priorities shifted massively to cope with the lockdown and cope with the pandemic. and businesses or councils coming back now are dealing with a backlog of all kinds of things that got shelved for that. So projects like this, I think innovation, certainly anything that was badged as innovation rather than essential, is not top of the queue, and disappointing from my point of view, but understandable. There in agriculture, there's good examples where things like soil moisture monitoring across farms, in vineyards, all kinds of different things is being done at scale. So yeah, there are good examples now. And as soon as I can do a sales plug, if you come to the Things conference in September in Amsterdam, there will be bigger businesses than mine, much bigger businesses than mine, talking about large-scale rollouts that they've done. So yeah, they are existing. Hello.
I was wondering how mature the protocol is, because one thing that could happen is if that's shown success, you end up with thousands or tens of thousands of receivers for different networks maybe, and you have millions of devices. Is there a chance that it can saturate the spectrum that's needed, or sometimes stuff like pollution avoidance built in ready?
Okay, so the question there was how mature is the Lorawan protocol, and I think I can shorten it to if everything is on 868 megahertz, won't that fill up? Which is a concern that I heard in 2015, 2016, 2017. I wish, if that happens, then we've won. But no, there is. So to answer your question more seriously. When I started, Lorawan was, I think, version 1, and it's been through 1.01, 1.02, I think it's on 1.03, and there's a 1.04 in the works, I think. So it has matured. It's owned by a company called Semtech, who are an enormous company. So you've got LoRa, which is the radio side of it. Lorawan is the bit that adds on the connection to the internet, and it's based on technology developed during, I think it was the World War II, where they're able to. It's a technology called. It's chirp, and it's spread spectrum, and it's a different talk, and it's about another half an hour for me to explain quite how it works. But it's very good at, so everything's really low power, and it's very good at making sure signals get through the noise floor. It seems to work very well. There are limits on gateways in terms of the amount of messages it can receive concurrently. At the moment, the answer to that is densification, so putting more gateways out, and that's, that seems to be working very well. So theoretically, yes, there is a potential that one day that spectrum will fill up. I think there's always been a worry that you could maybe block that spectrum somehow. I've seen theoretical papers about it, like research papers about it. I haven't heard anywhere where it's happened in practice. Hi, Stuart.
I was just going to ask about heating networks. I know there's a closed networks, things network, open network. I think there's something probably this at the moment where they're cycle essentially the same technology. I think there's some other closed networks technology.
Sorry, I missed that last bit. Right, okay, so that was a question about competitors. I'm going to answer it in two ways. So there are competitors to Lorawan as a technology. So within the low power wide area network family, there is Sigfox, which they did go. This is going to sound worse than it is. They did go bust earlier this year, but they got bought by a company called Unibiz, which is, you know, means that it's got a life going. That has been used quite a lot around water meters, so well, metering and things like that across Europe. It's a French company, so it's got more of a foothold there than in the UK, I would say. So that's one. But the bigger competitor in the LP1 market would be narrowband IoT, which is the mobile phone technology's response, a very late response to the LP1 market. So it got caught napping, really. The whole mobile phone industry got caught. And they have deploying now narrowband IoT in the UK. Vodafone have got some of the way across the country. O2 have gone the other way. There doesn't seem to be a huge amount of motivation from the mobile phone companies to really, I suppose, eat their own revenue from their other kind of IoT offerings. So I don't know. I mean, I think if they went for it, then there's huge potential for narrowband IoT. I think it could work really well. You know, the service level that you get from a Vodafone or someone like that ought to be way ahead. But as a system, it's very underdeveloped compared to what you see in Lorawan solutions. So that's the first part of it. There are competitors to it. Some of them are very good. Perhaps the other side of things is Lorawan competitors. So the Things network doesn't own Lorawan. You know, it's one version of it. There are lots of other companies that do it. One that has been in the news over the last couple of years is Helium. Anyone heard of Helium? They it grew very quickly in America. The gimmick with it is that you what are those things called? It's not Bitcoin, but it's, you know, it's got its own version of a Bitcoin, a cryptocurrency. That's it. And so that it's used that as a bit of a gimmick to try and get lots of people deploying it. But there are more. So this is a bit of a personal point of view, but there are more serious companies out there. So the Things Industries, Laureate, Orbywise, oh blimey, and others who are offering a professional, you know, commercial offering of LoRaWAN. So there's lots out there. I think that's what makes it exciting. So one of the initial concerns for Smart Berkshire was, well, what happens if the Things Industries goes under? Because it's only a small, you know, at the time it was a very small company. And what happens if they go under? Well, the technology is such that we can just switch to another provider. We don't need to change the gateways other than change the network server they point to. So the investment in kit is more enduring because there is competition, I think. Does that answer your question? Oh, I didn't mention Sidewalk. No, I don't know enough about it. Yeah, it sounded very exciting. Last year, was it, or the year before? It sounded very exciting last year or the year before, but I haven't. No. Yeah. Yeah. Yeah, they could do. You know, the potential's there, certainly. And then there's a question as to whether they open that up or whether they keep it for themselves. I'd be surprised to see AWS operating as a network operator. I don't think that's their market, but I've no idea.
Just a tiny comment to that, if I may. That's part of the answer to my before the question. So, in the experimental stage, they're using it, and they want to make a serious application. That's what the highest service levels.
Yeah, I think that makes sense. So the statement there was that maybe people will start off on a community type network and then move up into a professional service level, proper managed service. That's exactly what some of the councils are doing. So yeah, I think so. Once you know that it's going to work for you, then and you start putting your services on it as a council, then you want someone to slap if it goes wrong, don't you? So it makes sense. Chris, do we have any questions off of the? Why are you still talking?
Hello, Mark. There's a question for you from Paulette.
Sorry, is it on the chat?
Yes.
I've got Michael talking as well. So.
Yeah.
Oh, I can't. Oh, from Paulette.
Yes.
Oh, I know her. What was her question?
Hi, Mark. You work for Berkshire-based businesses and councils.
Have I worked on projects with other Thames Valley councils? The councils involved in Smart Berkshire are Reading, Wokingham, West Berkshire, Bracknell Forests, Maidenhead, and Windsor and Slough. So I've worked with those. In the Thames Valley, I don't think I've worked with any others. I'm very sorry if I have. Off the top of my head, I don't think so, no. But I have worked with, it's about 15 or so councils around the UK now.
Hi, Mark. It's Paulette here. Thank you very much for answering my question. A fantastic presentation. And what you're doing is really great. And maybe at some stage we should have a catch up, because I've got a project in mind that maybe I would like to talk to you about.
Brilliant, love that.
Okay.
That'd be great, thank you. Okay, you were first.
Yeah, Krishna here. So new to Lorawan. So you showed us the case of how the things work at the back end.
Yeah.
So on the devices, so what's the Lorawan component? Sensor, what's the size of it, and how much it costs?
For once, sorry, the question was, on the devices, what is the size of the Lorawan component and how much does it cost? All of which are good questions, and stupidly, I haven't brought a device I've made myself here. But what I can do is probably take this one apart and show you. But the devices have got smaller and smaller. So when I started, it felt like they were about 1 inch long. Now they're kind of baby fingernail sized components. And you get modules now that will just, you can just drop on. I couldn't tell you the costs off the top of my head. I know they have dropped significantly in the past couple of years. When we started this, I was quite interested in making devices. I have to say that it's hard and harder than I thought. And so I think now I'm much more interested in using other people's devices that have been designed properly and manufactured at scale. So whereas we can do nice working prototypes at small volume, to actually do the design for manufacture work and scale that up is beyond what I'm able to do in my company. So that would be a point at which I would want to work with other people.
Talk in the early days about positioning. That comes faster and still just bidirectional.
Right. Okay. So that was a question. So there was talk in the past about positioning. You mean like geolocation?
To be able to look, yeah, to be able to locate where you've been in when it's not when it's not.
Yeah. So you're right. And it is in the Lorawan spec now. So modern gateways can come with the ability to do geolocation. So if you can imagine, in Reading we've got maybe 20 gateways up around the town. If your device transmits a message, then that may be heard by 4 or 5 gateways in Reading quite conceivably. They can use time of flight to triangulate the location of that sensor. I did some work with Digital Catapult a few years ago, and I know there was a guy there who was doing trials with a public sector organisation, tracking devices, tracking objects around a space, and that was working reasonably well. There's been quite a few trials I've seen. So in terms of resolution, you're talking about maybe within the nearest 50 meters, rather than, like GPS will get you to 5 or 10 meters. It's not something I've watched recently to see how much that's changed. I think people are doing GPS or geolocating in interesting ways now. There is in the latest Semtech chips, I think there's some geolocation stuff that will make use of Wi-Fi signals as well as LoRaWAN. So there's a sort of combination effort to get the geolocation. There's a huge market in it if you get it right. I think for things like tracking ships at sea, then to the nearest 50 meters is brilliant. That's right. Yeah, that's it. So yeah, does that answer your question? Yeah. It's. I have to say, it's not something that I've been asked in the last couple of years. So I'm not sure really where it's moved. After I've been to the Things conference in Amsterdam, I will know everything, I'm sure. So. Hello. How much are tickets? Oh, that's a good question. No. So have there been projects with kids? So I've worked with UTC Reading. I don't know, do you know them? They're the technical college. So with, I think they're about 14, 15-year-olds. And so I've run workshops with them. I've run similar workshops in Ipswich and in Wales. So where you get kids programming Arduino, seeing data appearing on the internet and building a dashboard so they can actually see stuff. One of my favourite projects, it was with an agricultural college in Northwest Wales, Cleveland College, and we worked with farm students there, coming up with ideas. So this was early doors. This was like 2016 or 17. I think coming up with ideas for what they could use on the farm, and then showing them how to build some devices or how to get some stuff working. And then we turned the farm into a digital playground. and invited local farmers and local businesses in to come and see that. That worked really well. That was funded through a company called Mentormon, who then went on with Gwynedd Council, and they went on and did a whole year of IoT the following year, looking at things like dogs harassing sheep, those kind of use cases. It was really good. I think there's lots of opportunity to work with kids. Mike showed you in his video at the Merle, there was a device made with a microbit, BBC microbit. So they call them a shield, I think, don't they, that goes onto that. That was designed by a guy at the Hackspace called Richard, and that was something that we thought would work really well for schools. A company called Pies, I hope I'm getting this right. Apologies, Pi Supply, if I didn't. A company called Pi Supply designed something similar, and then was able to find quite a good market, not in the UK, I have to say, in Europe for microbits with the Lorawan bits added. So yeah, around Europe, there's a lot of interest. There's an amazing, I've forgotten their name as well. They're based near Amsterdam, and there's a double-decker bus that is essentially a hack space, and they get kids in and they teach them Lorawan, they teach them programming, they teach them soldering, and they're able to build stuff. And it would be fantastic to do something like that here. Haven't seen anything quite as well done as that in the UK, but yeah, plenty of potential for it. Okay, I think then we'll call. Oh, what's this?
Talk about the conference. The details.
Oh no, it's right. So, I'm being offered now the sales pitch for the conference, but I think I've said enough on that, and I don't get commission. So, okay, I think then we'll call it a day at that.